Hello everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, I will talk about identifying if the given function is odd or even. Alright, so before we jump straight into the very first example, I recommend that you check out the description box because the links to the other videos that are related to this topic are posted there. Alright, so here are the concepts that we will be using later on in answering a few examples about even or odd functions. We call it the algebraic way of identifying if the given function is odd or even or neither. All right, so you will be performing a short step in which all the variable x in the given function will be replaced by negative x. So after replacing all the x's by negative x, then you need to simplify. And if it happens that f of negative x is equal to f of x, or say the original given function, definitely the function will be even. All right, on the other hand, the function will be considered odd if, after replacing all the x variables by negative x, if all the signs from the original function were turned to its opposite, therefore the function is considered odd. That's why you have here f of negative x is equal to negative f of x. There are times the given functions are neither even nor odd. Any of these two is not followed, definitely we're looking at neither even nor odd function. So let's take a look at the very first example. Identify if the given function is even, odd, or neither. So for the first one, we were given f of x equals 7x squared plus x to the power of 4. So what we need to do is we need to replace all the x's by negative x. So 7 and we simplify. So f of negative x equals to 7. So negative x to the power of 2 is x to the power of 2 plus negative x to the power of 4. So simplifying it, so negative x times negative x times negative x times negative x is so positive x to the power of 4. So after simplifying, then you need to compare. So this is the result after the algebraic manipulation, comparing it to the original given function. So as you can see, they are the same, right? Since f of negative x is equal to f of x, or the original function, therefore the given function is even. All right, let's take a look at the second one. G of x equals negative x to the power of 5 plus 2x cubed plus 13. Become g of negative x equals negative times negative x to the power of 5 plus 2 times negative x to the power of 3 plus 13. And then we simplify the right hand side. So you have negative. So simplifying this, negative x to the power of 5 is going to be negative x to the power of 5 plus 2. So simplifying this, So negative times negative times negative is negative. So that means it's going to be negative x to the power of 3 and then plus 13. Then we simplify. So here negative times negative is positive, so it's x to the power of 5. And this one will be negative. So 2 times negative x to the power of 3 is negative 2x cubed plus 13. All right, so let's compare the original function and the result of the after the algebraic manipulation. So this is the result. This is the original. You notice that the first term, so from negative it became positive. So second term from positive became negative, right? But the third term is the same, right? So positive 13 and positive 13. So basically, not all the terms were changed to the opposite, only the first two terms, right? So the rule is all the signs of all the terms should change to opposite in order for it to be considered odd. But basically, since the third term fails, right? Definitely this function is considered neither even nor odd. And for the third example, so we were given h of x equals cube root of x. So the rule, we change the x. We replace the x by negative x, so it will be cube root of negative x. Right? So which is actually the opposite of the original function. So from here, we can see that h of negative x is equal to negative h of x. Therefore, this is odd function. All right, so do you find it easy? So let me know your feedback by leaving a comment below. All right, so let's take a look at the second question. All right, so by just looking at the graph, definitely you'll be able to identify whether it's even, odd, or neither. All right, so this is another method, okay? So for the first part, we talked about algebraic investigation. So this one is actually the graphical, okay? Now, there are two things that I need you to focus on. All right. So for this concept in which you are presented with graphs, so we're going to be talking about here symmetry. Now, so when do we say if the graph represents an even function, right? So we can say that the graph represents an even function if it is symmetric with respect to the y-axis. What does this mean? So it only tells us that if the graph is symmetric with respect to the y-axis, definitely we're looking at the y-axis as the mirror of reflection. Now, when is the graph considered odd? All right, so if for even function, we're looking at symmetry and we're talking about reflection. For odd function that is represented by a graph, we're going to be looking at symmetry with respect to the origin. If even function is about reflection, odd function is about rotation. So definitely we're talking about rotation of 180 degrees about the origin. Now, let's take a look at examples 2a and 2b. So 2a. So we were given this graph, and which of the two is the answer? Is it even or odd? So based on what I discussed earlier, since here you can see the y-axis. So this is the y-axis. And the y-axis serves as the mirror of reflection because you can see that the graph is symmetrical, right? So basically the first one, example 2a is an even function. And example 2b, okay, you can see that the graph is symmetric with respect to the origin, 0, 0. It's like if you have a point here, say that is at 1, 2, and the other one is here, which is -1, -2, at -1, -2. And as you can see here, applying the concept of rotation, so it's like rotation of 180 degrees about the origin. You can see. And it's gonna form like a straight, that's a straight angle, so 180 degrees. So basically there's a rotation of 180 degrees about the origin that took place. So also, if you pick other points from here, for example, this one and that one, so about the origin, it's a straight line. So 180 degrees rotation. Therefore, example 2b is odd function. Now, if the graph that is presented doesn't follow any of the two conditions, definitely we're looking at neither even nor odd. So prepare your pen and paper and answer the challenge question. Examine the table and determine if the table represents a function that is even, odd, or neither. All right, if you know the answer to this question, please leave a comment below. And if you haven't subscribed yet to my YouTube channel, please do so. And it's Math Hub by Mr. H. And once again, thank you very much for watching my videos and supporting my channel. It's a great help. And I'll see you on my next video.